My name is Professor Wunderlich, and this is an introductory high-tech course in computing. And we're going to talk about hard drives here in this lecture. First thing before we look at a pre-recorded lecture that I had done before is this example you see behind me here, in that I paid $1,000 for a 10 megabyte hard drive, 10 meg, in 1982. That was 40 years ago. I'm 60 years old now, so that was the first PC. It was a compact computer. It was the first IBM clone, and Macs didn't do anything back then. So it was the very first time you could use any kind of word processing or spreadsheets. And so if you equate that, 10 megabytes is 10 to the 1 times 10 to the 6 is 10 to the 7 bytes, and for $1,000, that's 10 to the 3. So 10 to the 3 divided by 10 to the 7 is 10 to the negative 4. And then adjusting for inflation, so $1,000 in 1982 is equivalent to about $3,000 today. There's online calculators, you can look at that. And so what we get here is approximately $3 per 10 to the 4th byte, or 3 times 10 to the negative 4th dollars per byte. And then today, I just looked up for approximately $200, you can get a 10 terabyte, hard drive, internal hard drive. And so that's 10 to the 1 times 10 to the 12 or 10 to the 13 bytes. So bringing down the math from up here and the math from over here, 10 to the 13 times this amount of dollars per byte. So I ask the question here, so what is the equivalent dollars in 2022 dollars if I paid the cost per byte from back here? So this unit cost per byte, but in today's reality. So that's 10 to the 13 bytes times 3 times $3 and at the 10 to the negative 4th per byte. So that's approximately 3 times 10 to the 9th, or $3 billion. So if I was going to pay that cost per byte that I paid back then today, I'd be paying $3 billion for this drive that I can get for $200. Okay, so that's just to show you how costs of things have come down, or yeah. All right. So let me share screen now. Okay, and this is my website. This is going to be the easiest to find. We also have a Canvas database, but since I'm going to post this on YouTube, somebody in the future or outside of academia might want to drill down. This website should be up for a good long time, a decade or two more. And there'll be links to take you somewhere else when I get up in the hundreds. So anyway, this is a number of things that I do. And you go to the syllabi here. I've taught 40 different courses over the past 30 years, and we're in this course right here. And we're down in here, so we've covered all these things here. I've grouped them into chunks here. We did memory last time, but storage is different. Storage is external to the computer. Memory is, quote unquote, memory is your DRAM, your dynamic RAM, but you also refer to memory as your static RAM caches and the registers, and stack and everything. But storage is a completely different thing. That's external. All right, so we're going to go in here. I'm going to play. So you'll find in YouTube, if you want to click on links and things, you go down, there's a PDF in the comments on YouTube, and you can get to the MP4s as well in there. I also have PowerPoints with embedded audio, but they're not as nice to lecture and wrap around because you can't really stop the slide in the middle so easily. MP4s at YouTube's you can. Okay.
My name is Professor Joseph Wunderlich, and this is a lecture on storage. This is a supplemental lecture. We'll talk about this already a little bit, but not in any kind of depth. Storage is different than memory, including main memory, which is RAM, and the caches, which are static RAM, or the registers, which are static RAM. Main memory is either a disk type storage or tape drive or flash drive, optical drives.
I actually misspoke there. Storage is the drive, is the optical hard drive. Storage is either going to be magnetic, moving parts, optical with a laser on disks, bouncing off of disks, or solid state, no moving parts. So we're talking about storage now.
So in the beginning, storage was early tape drives, big reel-to-reel giant tape reels, seen movies, and it was eventually replaced with tape cartridges, and then for cheaper and warehouse, big robotic tape archives, huge facilities. At IBM, we had something the size of about 4 basketball courts with a robot that would run up and down the aisles. And it was a good 15, 20 feet tall. It's not like this picture I've inserted here. IBM invented disk storage in 1956, and in San Jose, helping to start the whole magnetic storage industry. Then the moving head disks led to the disk drives of today started becoming extensively used in the 1970s. And this Winchester disk is developed by IBM in 1973 is what pretty much the standard of how things are made today. Pictures, some systems. The historic role of IBM and disk drives tapered off and so it came to a complete end in 2002 when IBM sold its disk storage division to Hitachi. So IBM, when I worked there in the 90s, prided itself on making everything, pretty much everything. Fabricated on chips, on processors, on RAM, motherboards, and all different size machines, and then all the software from systems level and operating systems on applications. And you can maintain better quality control that way, and dominate markets too, as they did for many, many years. Now, flash memory is a relatively newer thing. Although it was invented by Toshiba in the 1980s, it hadn't become cheap enough for everybody to buy until this millennium, but we all have thumb drives with flash memory we carry around. And this is solid state. There's no moving parts, which is very nice, unlike the magnetic drives. This chapter here doesn't mention optical drives for some reason, but the CDs and optical discs are certainly another type of storage. Now this chapter also puts something here about databases. And so although there had been storage of punch cards and later magnetic tapes, the emergence of the magnetic disk led to modern databases. So that's the tie of why it's in here. It's a direct result of large-scale storage of data. That's the creation of the database. So General Electric is credited here in 1961 for some of the first databases using magnetic storage, and then not too long after, 1968. Before my time, I was only 7 years old then, but my father did work quite a bit on Apollo missions. And so they're mentioning that here IBM had introduced the IMS, which was derived from IBM's work on the NASA Apollo project. SQL, which you learn now in your databases, for database courses invented in the 70s by System R. And relational databases maturing in the 1980s, and IBM DB2, familiar with that. I worked inside that in the 1990s. Also object-oriented databases and parallel processing. Now, RAID arrays have been around for a long time, and that's just a redundant set of drives. Berkeley, UC Berkeley's done quite a bit. San Francisco Bay Area, Berkeley and Stanford. So RAID stands for Redundant Arrays of Inexpensive Disks, mainly for servers. Chapter always also has a little bit about networking here. So wide area nets, WANs versus LANs. And so in the beginning of the wide area networks was the ARPANET, it was a military Cold War connectivity between a number of universities in the United States and funded by ARPA, which is military government project. And TCP/IP was the protocol for how its information was broken into packets and delivered. And so, spoke about that a little bit in another lecture. This is stuff of the whole course you should take on networking. And the key application of the internet and the World Wide Web. The key application of the internet is the World Wide Web. So the internet is a network of networks, hardware infrastructure from the 1960s that was in place and developing from that time, but not until Tim Berners-Lee in Switzerland made the HTTP hypertext protocol could the World Wide Web come into play. And lastly, local area networks, which is just a smaller version of what evolved from the wide area networks and DARPANET. So researchers in Silicon Valley, near Stanford, Xerox Palo Alto Research Center, Stanford's in Palo Alto, had been funded by ARPA while working at universities, and they all know the value of networking. And this group invented the Alto and the Ethernet, which is the very first use of local area networks. And just some further reading references. And a couple more references. Mr. Feld.
Okay. I should mention that what you see here, this is excerpts from a course textbook we've been using here for a while. Been teaching this course for 23 years at Elizabethtown College. I also taught at Purdue University and at the University of Delaware and San Francisco State University and the University of Trento in Italy. This is the red, as you'll see, comments and updates that I've done. This book, by the way, is a standard in most schools and for computer architecture courses. The Hennessy book, and it was written by the president of Stanford and the president of Berkeley, both high-tech people, and it's a well-known thing. And then I've updated it, so that's what we're doing here. Right, stop sharing. Okay, that's it for this lecture here. I'm starting another one.